Find the amount at the end of 5 years of an annuity of 6,000 payable at the beginning. Beginning denotes that it is annuity due of each quarter until 5 payments. Now point to notice that this is 5 payments, not 5 years. Have been made if money is worth 5% compounded quarterly. Let us first make a timeline. Today is year 0 and we have to calculate the amount at year 5, and we will have year 1, 2, 3 and 4 in between these 2 years. The interest rate is 5%, we know that. However, we are depositing an annuity of 6,000 rupees at the beginning of each quarter only 5 times. Therefore, we must have deposited this amount at, let's say, 1st January. The second quarter will start after 3 months, that is after Jan, Feb and March. So the second will be on 1st of April. The third quarter will start after 3 months, April, May and June. Therefore it will be on 1st of July, 6,000 over here, 6,000 over here. And the last quarter of the year will start after 3 months from 1st July, which is July, August, September. Therefore it will be 1st of October. 1st October, 6,000 on 1st of October. We have made 5 payments or 5 deposits, or there are 5 annuities. Therefore the last amount will be on 1st of January of next year. Over here 6,000 again. So there is an annuity of 5 payments, 6,000, 6,000, 6,000, 6,000 and 6,000, and this is an annuity due. If we are talking about annuity due and we use the future value formula, it will give us the value of this annuity at 1st of April next year over here. If I apply the future value formula, it will give me the future value of these 5 payments over here on this spot, which will be 1st of April in the second year. However, I have to calculate the future value on year 5 and I am not making any deposits in this time period. So firstly, I will use the future value of annuity formula, calculate the value over here and then compound it for this time period. So step number 1 will be to use the future value of annuity due formula, which is S is equals to R multiplied by 1 plus I power n minus 1 over I multiplied by 1 plus I. And yes, since it is compounded quarterly, we will divide the interest percentage by 4 and multiply the number of years by 4. So S will be, S is equals to 6,000 multiplied by 1 plus I is 5% divided by 4 power n. Now point to note is that if we have 1 year and compounding is quarterly, we multiply it by 4 and say n should be 4. If we have 2 years, we multiply it by 4 and say that n is 8. So basically this 4 is the number of payments and this 8 is also the number of payments. How do we compute it? We multiply the number of years by payment in each year, which gives us number of entire payments. In this question we are not given number of years, but we are directly given the number of payments, which are 5. Therefore n will be directly 5 minus 1 divided by 5% over 4 multiplied by 1 plus 5% divided by 4. Now if I solve this, if you use your calculators to solve this amount and compute the value, what is this value? It will be it will be 31143.9. 31143.9. Now this value is over here, 31143.9. We have to take it forward 5 years. So we will use S is equals to P1 plus I power n, and the future value will be present value, or 31143.9 multiplied by 1 plus 5% over 4, because compounding is quarterly, power n. N is again number of time periods. We have 1, 2, 3. 3 complete years. 3 complete years multiplied by 4 will give us 12 time periods, and this time period is not the entire year, but it represents 3 quarters. So therefore our n will be 15, and the future value will be 37523.07. This will be your final answer.